Hi, Stuart.
Thank you very much.
Thank you. Well, good afternoon, folks. Welcome to another session of the Essex-based Thought Leadership Series. It's a great pleasure to work with BT on this, and we thank Sarah McKenzie for all her help, and also my colleague, Jordan Deere. Today, we have another colleague who stepped up to the mark, Somdip Dey, who has a large background in his topic today, and even has a company, I read, to help people stop wasting food. So it's extremely topical. So without any more from me, the topic today is AI, IoT and blockchain being the future of food security and reducing waste. So over to Somdip. Thank you.
Thank you so much, Stuart, for the introduction, and thank you everyone for joining this session. Before we move with the talk itself, can you just confirm that you can hear me properly?
Okay from me.
Okay, great. Thank you so much, Stuart.
Yeah.
So again, I am Somdip Dey. I am a lecturer at the University of Essex. I lecture on computer science topics, and I'm also the CEO of NOSH Technologies, where we are utilizing cutting-edge technologies such as artificial intelligence, blockchain, cloud computing, and edge computing to fight food waste. And the topic for the talk, as is already introduced by Stuart, is AI, IoT, and blockchain being the future of food security and reducing waste. Now, before we move on with the actual content of the talk, first, I would like to show you a clip. This was taken by our undercover agent at one of the supermarkets, a very popular supermarket in the UK. Now, I wouldn't name which supermarket it is because it's not just an issue with the supermarket itself, but with all the supermarkets in the UK and shops as well. So let's watch this very short clip. So as you can see, this is only one skip, which is completely full with thrown away food that is completely edible. These food are thrown away because the best before date was yesterday. So most of the supermarket and shops are actually legally not allowed to sell product, even if they are completely edible. If they are past the best before date, they are thrown away. But as you can see, the amount of food there is, it can feed a lot of people. Yet, we have a lot of hunger around the world. Now, you might be thinking, okay, what is like a scientist like me doing or fighting the cause for food waste? Most of us are aware of food wastage, but we end up doing something about it. But why embedded machine learning scientists is very invested in this topic? So it starts all back in 2013. So I moved from India to the UK to pursue my master's at the University of Manchester. In 2014, when I was completing my master's, my parents went through a terrific car accident, which caused severe injuries to my mother and also paralyzed my father. Now, to help them with the medical procedure, I ended up giving away all my saving to them to help with it, without realizing that I didn't have any money to buy food for almost 1 week till I got paid from the jobs that I was doing at that time. So there were many nights, like when I would go to bed hungry because I didn't have money to buy food. What I ended up doing is I dumpster dove. So I went to dumpsters and found completely edible food, and I survived on them for almost a week. Now that showed me that how many people throw away completely edible food in the bin because it is inconvenient for them, or because they are worried that what if they get food poisoning because the best before date has gone past like 1 day or 2 day. Now, end of 2014, given this experience with food waste and my own hunger, I ended up co-developing the world's first crowd food sharing platform that enables the user to share their leftovers and food surplus with other people in need. Now, this application, when it came out, it was made open source and it inspired a lot of entrepreneurs in the coming years to develop similar solution to join in the food waste fight. And this also gave rise to its own industry of personal food waste reduction, which is currently, like today, worth more than 200 billion. So being the granddaddy of such an industry and an early adopter of technology that helps people to reduce food waste at home and for personal usage, since 2014, I have only noticed that the food wastage statistics has scaled up as the population has grown over the years. So we have many applications today that are helping people to reduce food waste, but still the food waste statistics has not gone down. So according to FAO, every year, more than 1.3 billion tons of food is wasted, which is equivalent to $2.6 trillion. So with that amount of money, you can buy Apple and Tesla together. It's that much amount of food is wasted all around the globe. Whereas more than 820 million people around the world do not have access to proper nutrition, even with all our food wastage. On the other hand, food wastage also contributes to almost 10% of the global carbon emissions. Now, almost 70% of the total food wastage happens in retailer and consumer level, and 30% of the food wastage ends up happening at the production or processing level. So given that I have been following this food wastage industry for a long time, so the key questions that came in my mind, because I wanted to do something about this, is how can we collect accurate data on food consumption and waste without threatening users' privacy? How can we raise awareness among the consumers about food waste so that they become more conscious of the social and environmental impacts that it has? Also, the question that is raised is how can we actually help the consumers to reduce waste and save money, especially during a time when the cost of living is steadily growing? And how can we help each stakeholder in the food supply chain, which includes the production, processing, distribution, retailers, and consumers? How can we help each of these stakeholders to reduce waste and improve sustainability? Now, I don't know about others, but personally being a machine learning scientist, from my personal problems to professional one and to external ones, somehow I end up building software that uses AI in some form to resolve these challenges. I don't know if it's true for others, but that's true for me. So when I started doing research in the machine learning field and in AI, so I thought, okay, AI could be an enabler to reducing food waste. So it was the aha moment for me personally. Now, before we proceed, I would like to introduce a term which is embedded machine learning. So most of people have at least heard about artificial intelligence or machine learning. So machine learning is the field of artificial intelligence where the machine is capable of learning patterns from the data and then make decisions based on it. Whereas embedded machine learning is a subfield of the machine learning where the machine learning model is run on embedded systems or embedded devices with limited computing resources, such as wearables, edge devices, microcontrollers, etc. Now, what is the biggest benefit of using embedded machine learning over other form of machine learning? When it comes to artificial intelligence and machine learning, many users or consumers are actually worried about the privacy and security of their data. Now, because embedded machine learning is run on the user side, so the privacy and security of the data is maintained on the user side itself, because the model learns on the user side and then either makes a decision on there or pass the decision at a later phase to do further processing. Now, we have someone raise their hand, Andre Thompson. Out of curiosity, Stuart, are we taking questions now or should we leave it till the end of the talk? Stuart? Sorry, I just needed to confirm this one.
Somdip, it's Sarah. I think you can offer questions throughout. It's up to you.
Okay, perfect. Yeah, I'll take the question then now. Okay, Andre mentioned it was accidental. No worries, Andre. Thank you so much. Anyhow, if you do have questions as I go along with the talk, please do ask me and I would love to answer. Thank you so much. So again, like just a quick recap, the best part about embedded machine learning is that because it runs on the user side, the privacy and security of the data is maintained, while at the same time, the machine learning model is capable of like learning from the data and taking further decisions. Now, if you can recall the questions related to the food waste that I have shown earlier, so the answer to all those questions is actually what we have developed at the University of Essex is the personal NOSH assistant, or we simply call it NOSH. Now, NOSH is the B2C side for from ours, from our side. So NOSH app is the artificial intelligence powered all-in-one food management and consumption application to help the user optimize consumption by managing food more effectively while reducing food waste at home, living a healthier lifestyle, and save money. So within the NOSH, we offer 3 distinctive services to optimize food consumption, save money, and reduce food. The first service is the NOSH Food Management, which enables the user to manage food more effectively, get smart recipe suggestions on the bought food items, get in-app shopping planning feature, and it also has intelligent analytics on food consumption powered by our own in-house embedded machine learning model. The second service that NOSH offers is NOSH Daily, which is the using it, the user can get daily deals and offer on food products, including groceries. They can also get latest news and media content on everything food related. So NOSH Daily's purpose is to raise awareness among the user about what's going on in the food industry so that they can take better decisions about what they need to do in order to reduce food waste and lead a healthier lifestyle. And the third service that NOSH offers is NOSH Shop, which enables the user to buy food product, including groceries, at an affordable price And at the same time, NOSH Shop is able to feed hungry and malnourished people through every purchase made through this service. And on the business perspective side, using this service, the food vendors and entrepreneur and retailers can share or sell food to other people nearby. Now, so what is so special about NOSH? NOSH provides an in-app intelligent data analytics on food consumption and wastage such that the consumer can take data-driven decision on what food to buy or not to buy the next time they go out shopping in order to optimize waste. Using embedded machine learning on NOSH, it is capable of learning what type of food is consumed or wasted in which region of the world without threatening the user's privacy. Now, NOSH has already helped more than 17,400 consumers to save more than 200,000 different types of food items and reduce carbon emission by more than 127 tons. NOSH is also one of the largest repository of the food consumption and wastage data in different regions of the world, as the app is currently available in more than 176 countries in the world. And this data is especially very valuable for all the stakeholders in the food supply chain, because they can use this data to make better decisions on how to optimize waste at their level in the food supply chain itself. Now, you have seen our commercial app that is used like on the consumer end, but the backbone of the NOSH app is supported by two key innovations that we are going to explore today in this talk. So the first innovation is digitizing food supply chain data using blockchain to make it more easily accessible and traceable to any stakeholders in the food supply chain to improve food safety. And the second key innovation is using machine learning and blockchain to optimize waste in the food supply chain to reduce waste and improve sustainability of the planet. Now, before we move forward with each of these innovations, let's quickly explore some of the key topics that we need to understand as part of the innovation itself. Many of you might have heard of blockchain or cryptocurrencies, but let's take a brief look at what is blockchain in general. So a blockchain is a digital ledger, or in other words, a growing list of records, which are called blocks, which are linked together using cryptographic functions. So imagine this is a representation of blockchain where the records are stored in blocks. Now, if we assume that, let's say, the block of data is capable of holding a data size of 5 MB. So in this block, every record or every action that is taken is called a transaction. And the transactions are stored in the block till the capacity of that block is fulfilled. If the capacity is fulfilled, then a new block is created, and in the new block, which is created, let's say if we call it block 11, we perform a hash function on the previous block, and we store the hash value in this new block along with the timestamp of the creation of that block and further transactions that are performed on that block itself. And we keep on like producing new blocks of data as the data increases on the blockchain. Now, The key features of using blockchain is, first of all, it is decentralized. Now, when you go and use websites like Facebook, Google, Twitter, all your personal data is actually maintained and stored by centralized entities such as Facebook, Google, or Twitter. Whereas the concept of blockchain is completely decentralized, which means that the record or the data are not maintained by one particular centralized entity, but by different people or entities on the blockchain itself. Another key feature that blockchain offers is transparent. So any transaction or action that is taken on the blockchain is free to be viewed by other user or entities on the blockchain itself. So it is completely transparent in nature. In essence, when blockchain was introduced, one of the key features that it actually introduced was it was open source. So people can join in and improve the features of the blockchain and work on it. So if you want to use blockchain in your project, you can just fork the project itself and use it for your own purpose because it is open source in general. The other feature that blockchain offers is autonomous, which means whenever you make a transaction on the blockchain or take any action, that has to be approved through consensus by other users or entities on the blockchain itself. And one of the other benefit of using blockchain is immutability, which means that whatever record is stored on the blockchain is there on the blockchain forever. So we have a saying in the industry, what you do on blockchain stays on blockchain. So in case you end up using, let's say, blockchain-based social media network, for example, BitCloud or Diamond App, do be careful about what you put out there on the blockchain social media network, because even if you hide it, it is there always on that blockchain. It is not like Twitter that you delete and hope the nightmare is over. And the last key benefit that is generally offered by blockchain is anonymity. So in order to start using blockchain, all you need is a blockchain address. It doesn't have to have your name attached to it, but if you have the address, you can start using blockchain very easily as soon as possible. Now that we have explored that what is blockchain in essence, another key assumption that we need to make about the food supply chain, that in our research and our work, the food supply chain that we have dealt with is the farm to fork food supply chain, which consists of five distinct phases or stages. Those 5 stages are production, processing, distribution, retailing, and consumption. Excuse me. Now, since 2018 till 2021, although there are many standards available around the world, such as General Food Law in the EU, or the Food Safety Monetization Act, or in short called FSMA in the US, these standards try to standardize the traceability of the digital information of food production in some of the stages of the food supply chain. These standards are mostly regional, and currently, there is no holistic standardization of the tracking and recording of data for food traceability purposes in all stages of the food supply chain. So lot of different companies, especially for example, IBM and Walmart, they partnered together to digitize the food supply chain data using blockchain, because of all the features that it offers, as I have already mentioned. Now, because of the benefit that blockchain offer, several other researchers and industry practitioners have developed their own blockchain-based frameworks to digitize the food supply chain data to improve traceability of food products within the supply chain. But the biggest issue that happened, that how to make the data accessible from the blockchain. So the traditional way to explore data on the blockchain is to use something called Blockchain Explorer. So there has been studies that uses IoT or RFID to collect the data from the food supply chain and then store them in the blockchain. But users have to use Blockchain Explorer in order to access the data itself, which is not very useful, especially for day-to-day consumers who might not be very accustomed with blockchain itself. So the biggest question was how to make the blockchain data of the food accessible to the consumer side. Now enter the superhero, which is QR code. I'm very sure that most of you might have used or at least seen QR code in real life. And you must have seen them in different forms as well. So QR code is an effective information transmission medium, which is widely used in product traceability, advertisement, mobile payment, passport verification, and other fields as well. The reason being, it's so easy to implement and it's so easy to even access the data that is stored in the QR code and use it for further processing or in some other ways. So a quick recap, what is QR code or what it is capable of. So QR code is defined as 40 symbol versions to carry out different data payloads. And it also offers 4 user selectable error correction, which is capable of up to 30% of error handling. So QR code can be very beneficial in order to make the data on the blockchain accessible on the consumer side. And that's what we did. So one lesson that I have learned after like working as a software engineer in the industry for almost 13 years is that the best solution to engineering problems is oftentimes being the lazy developer. And we can also take this inspiration in research as well. So none of the other blockchain work that were available were able to make the blockchain data easily accessible for the consumer side. But what we did, we introduced QR code into that blockchain, and then suddenly it's now very easy for consumer to access that data, especially because with the growing population of Generation Z or Gen Z, these consumers are very conscious about what they're eating and how their food is sourced. So using QR code on top of blockchain makes it easier for these type of consumer to know where their food came from. And it also offers food safety as well. In case if something goes wrong, then the consumer can easily trace as well as report their food to the relevant authorities. Now, so our work is, we call it the food SQR block. So in that is the short form for food safety quick response block framework, which uses QR code in order to retrieve food data from the blockchain in the farm to fork food supply chain. And the representative block diagram of our food SQR blockchain framework is given here, where in each of the phases, the data is stored in the blockchain or blocks of data, and then QR code is made available for each of those food products, so that if someone or any stakeholder in the food supply chain want to access or know more about the food, they can just click the or scan the QR code and is capable of learning about the food itself. Now, currently, this feature is actually also live in our NOSH app as well. So NOSH users can share their food inventory with other NOSH users in a super fast speed. Comparatively, so other food inventory or food management apps that are currently available in the market through Play Store or App Store, most of them, in order to share data among their user, they use cloud storage, which costs thousands of dollars depending on how many users are using them per month. Now, using this technology, we helped to cut down thousands of dollars which would have otherwise spent on cloud storage. Now, that we are able to digitize the food supply chain data for traceability and accessibility, the next big question that we have, how can we optimize waste in the supply chain? Can someone guess like what we might be using? So if you put down in the chat, right now you have already seen we are using QR code and blockchain to digitize the food supply chain data. But what we can add on top of it in order to optimize waste? So if you want to add if you have the answer, or if you know what I'm going to bring next in the talk, I would love to hear in the chat. So what do you think is the solution to optimizing waste after we have already digitized the data of the food supply chain itself? Anyone? Add weight at each stage. Logistics? Not really, but thank you. So the solution, again, we started, remember, the topic of the talk is AI or machine learning. So if we are capable using blockchain and QR code, if we are able to digitize the food supply chain data, the next automatic step in order to optimize waste in the supply chain is using machine learning or a form of artificial intelligence. So our innovation in this space is, we call it the SMARTNOSHWASTE, which is a blockchain-based multi-layered framework utilizing cloud computing, QR code, and reinforcement learning to reduce waste in the food supply chain. Now, for some of you who might have heard of the topic of reinforcement learning or might not know reinforcement learning in detail, so let's take a brief look at what is reinforcement learning. Reinforcement learning is a type of machine learning algorithm where an intelligent agent or the machine itself which is itself a computing system that perceives its environment to take actions autonomously in order to achieve cumulative rewards based on the knowledge gathered from the environment. Now, I know it's a bit wordy, but let me explain it even in a more simple terms. Imagine on the right-hand side, this is a representative of an intelligent agent or a machine that actually learns from its environment by taking actions. And based on the action, it gets certain form of reward. Now, the goal of this intelligent machine is to optimize the actions so that it is capable of achieving optimal rewards. That's what reinforcement learning is in a nutshell. Now, as a scientist and engineer, we love to generate or create a mathematical formula to define like things in our daily life. Now, I don't know whether you have heard the TED Talk, where the TED Talk is about the mathematics of love. So we scientists have even formulated how we can define love in mathematics. So why not food waste, food production, and consumption in the supply chain, right? So the metric that you are seeing in front of us, this is the metric which represents the relationship between the food production, the consumption, the surplus, and the wastage. So in this equation, the P, C, S, and W are the total amount of produce for a particular food item, the total amount of the food item consumed, the surplus of the food item kept for food security, and the amount wasted of the food item respectively. Now, in the equation, you might also be noticing that we have YY, QX, and M. So these, the YY represents the year, QX and M represents the quarter, where the X is like which quarter it is. So quartile 1, 2, 3, 4, which is usually used in businesses. And N is the 3 months in each of the quarter, and M is each of the weeks in the month. So this is how we define the relationship between the food production, the consumption, surplus, and wastage data in the food supply chain itself. Now, this metric is very important because this will be part of the reward that we are going to teach or tell the reinforcement learning algorithm. Now, I do not want most of the attendees fall asleep by explaining each of the mathematical representation here. It's boring to a certain extent. So what I'm going to tell you that the metric that you saw, that can be actually valuable for each phases or stages in the food production, food supply chain. So as you can see, so production in each of the stages in the food supply chain can be represented using the same metric or same mathematical formula. And this diagram is showing only that. Now that we know the metric that we are using, I would also like to mention something, that because of supply and demand of the food production in the supply chain, the food production data among each of these stages in the supply chain are interdependent as well. So it's represented using this metric. So as you can see, if the food production data of the at the consumption stage of the supply chain, it's actually correlated to the consumption, surplus, and wastage data of the retailer stage. And each stages, like production data at each stages, are also interrelated based on this metric as well. So we have explored that what mathematical formula we formed the foundation for the reward. Let's look at the reward for our reinforcement learning algorithm itself. So if we consider a variable f that denotes the amount of food that should be reduced or increased in the food surplus to minimize wastage in that particular phase or stage of the supply chain, then the mathematical formula stands something like this. So we update our previous mathematical formula to introduce a variable called f, which is the amount of surplus that needs to be either added or reduced, or you can just keep it the same in order to optimize the waste itself. So based on this introduction of a new variable f, we can finally create the reward function for our reinforcement learning algorithm, which can be defined mathematically like this, where the reward function, so the goal is to minimize waste, which is actually performed using surplus plus the variable f, where the action that needs to be taken by the reinforcement agent, learning agent, is you can either increase the value of f, or you can decrease the value of f, or we call it down. And if you do not want to change the food surplus at all, you just keep the value of f as 0, or it does nothing, right? So these are the actions that the reinforcement learning agent would take in order to minimize waste, because that's the reward of the reinforcement learning agent itself. So the reinforcement learning agent of the SMARTNOSHWASTE is actually implemented at each stakeholder in each phase in the supply chain. Now, the goal is that if we optimize waste at each stakeholder level in each of the phases of the supply chain, then that leads to overall waste optimization in the whole food supply chain itself. Now that we have explored that how we are using reinforcement learning to optimize waste in the supply chain, so we implemented our SMARTNOSHWASTE to test waste optimization on 134,996 potato consumption data, which is collected through our NOSH app over a period of 1 year from December 2020 to November 2021. Now, after we implemented this SMARTNOSHWASTE's reinforcement learning, we noticed that we are capable of reducing waste up to 9.46%. Now, if you might be kind of thinking, okay, why we chose potato data, like potato consumption data, in order to kind of understand how much optimization of waste can be performed. The reason behind it, or the rationale, is that potato is one of the most wasted food in the UK and in the US. That's why we chose potato data from our repository of the data collected from the NOSH consumer app. And we noticed that using this methodology, we are able to optimize waste by 9.46%. Now imagine we end up wasting 1.3 billion tons of food every year. If we use this, and if it is capable of even reducing certain, some percentage of waste in the food supply chain, we are still reducing waste by billions of tons. So in conclusion, AI, machine learning, and blockchain are very effective in optimizing waste without threatening food security in the supply chain. Now, that being said, AI, machine learning, and blockchain are still in their infancy comparatively. And these methods that I have shown today are the foundation of what's about to come in near future. So we have a long way to go using these kind of cutting edge technologies to reduce food waste and improve food security and safety all around the globe. Now, that being said, thank you so much for being patient with me and enabling me to share our work with you. If you have any question, I would be taking it now, or you can also, if you would like to join in the fight against food waste, or you're curious about what we are doing with NOSH, you can email me at the email address shown on the slide. And if you want to explore what is NOSH up to, you can also visit our website, or we are also very active on social media, especially Facebook. And that being said, thank you once again. And if you have any questions, I would be taking that now.
Well, thank you very much, Somdip. That was brilliant. So have the virtual round of applause for that excellent talk. Thank you very much. So I've got one or two questions of my own, but rather than take advantage, perhaps people could ask their question or put their question in chat now, please. Here's the question then. Let's look. If you'd like to respond to that, Somdip, please.
So Anupam has asked, AI is helping us understand food waste reduction, but how is it improving users' food waste, optimizing other than notifying of upcoming expiry dates? So it's not just about expiry date. So on the user side, we are actually using other methodologies as well on the AI side. For example, NOSH Daily is powered by AI. So the NOSH app notices how the user is consuming news or media content related to food on the app in order to improve their, let's say, awareness of what's going on in the food industry. And as the AI learns how the user is interacting with the content, the AI pushes similar type of content to the user in order to help them understand and be relevant to the topic that they are interested in understanding or knowing. Apart from that, we also have NOSH Shop, which uses AI to learn what type of data is being or food is being wasted or being sold off very fast. This data is now actually provided to our B2B side of customers, which are actually the stakeholders in the food supply chain, such as farmers, warehouse managers, shop keepers or shop managers. They are getting better understanding of how the user in which region is consuming or wasting what type of food, so that they can actually optimize their waste on their side. So that's how we are using AI at different level. NOSH app that you can download from the App Store or Play Store is our B2C side only. We also have software for our B2B side, which is currently we are helping the stakeholders like the farmers, shopkeepers to optimize waste on their side using the data, which is learned by the embedded machine learning from the NOSH B2C app side.
Excellent. Thank you for that. Any further questions in chat? We have a couple of minutes. I've got my own question, but I give others a chance to ask their question before we close today. No, so can I permit myself then, Somdip, to ask you a question? I'm not an expert in this field. I found your talk very informative. What about really sensitive food poisoning issues like meat and fish and the like? Could you say in a few words how your app would save wastage in meat? A supermarket that sold off meat would be in the courts, right? There'd be a big headline. So it's obviously sensitive, but can your app help with meat waste, for example?
So currently, on the research side, we have developed, which is Food SQR block. The main purpose of using QR code and blockchain is to make it more traceable. Like if, let's say, they buy a food from one of the supermarket, which ends up giving them food poisoning, it might also be usual to think that the ingredients used in that food, which are also used in other such items, might also end up giving poison to other people or consumer as well. So we developed the Food SQR block concept in that purpose, but currently on the B2C side, it's not, that feature is not available yet. So currently user can share their food data with other NOSH users using the QR code system, but they are not able to report it yet, because right now, in order to achieve that, we have to have definitive contract with different supermarket, which we are still currently undertaking. Once we have solidified our financial deals with the different supermarket, then we will be introducing this feature in app on the consumer side, that they can also report directly through the app to the supermarket or like wherever the food is sourced from, so that those authorities can take further steps to take further actions on taking appropriate steps to deal with it.
Excellent. We have one final chat question, if you'd like to look, Somdip.
Yes. So Anupam has actually asked another thing. Thank you for answering that, Somdip. Just out of curiosity, what are some of the features you would be implementing in NOSH to make it even better in the upcoming future? So once again, it's kind of trade secret for now. So we cannot provide that data, because right now, although we are one of the industry leading food management companies in the world, that's why we have to keep some of our features a bit of trade secret. But thank you so much, Anupam, for the question. Unfortunately, at the moment, I'm not able to answer those because of company policies that we have.
Well, that's fair enough, Somdip. Well, I think we've run out of time today, so I'd like to thank everybody for joining in, and to virtually thank Somdip one more time for his excellent and informative talk. Thanks very much, Somdip. That was great. Okay, folks.
Thank you so much, everyone.
Thank you.
And
goodbye.
You have a good day ahead.
Thank you so much. Okay,
Thanks very much.
Thank you. We're closing now. Thank you very much.